All right. Welcome everyone to Energy Symposium for today, February 15th. Next week's speaker will be Rohit Chandra from Harvard University. He is going to talk to us about the history of coal in India. So if you want to know history of coal in India, next week is your talk. Today we do not have a talk on coal. We have a talk on energy efficiency, building energy efficiency from someone who spent a lot of time and has a lot of expertise in this area. So Richard Morgan spent a career in essentially building codes, green building, assessing green building codes. He used to work at Austin Energy, the city utility, for 20 years. And now he works for SPEER, the organization, South Central Partnership for Energy Efficiency as a Resource. That's the regional organization for Texas and Oklahoma for the larger energy efficiency organizations. And as part of this, he works on a Department of Energy program looking at energy efficiency. So Department of Energy's Energy Codes Field Study for the state of Texas. So he's going to give us a breakdown of the history of energy codes and tell us why Texas is at the forefront of building codes to a large extent, which some people might not think about. Texas is the forefront of building codes, but I guess it's hot here and humid, and we need to think about making our buildings comfortable. So without further introduction, Richard Morgan. Thank you.
Thank you, Dr. King. Yep. I think my mic is on. You can hear me? Yeah, I can hear the reverberation. So great to be here. Thank you for your time. As Carrie said, I represent SPEER and the South Central Partnership for Energy Efficiency as a Resource, and that's a name that carries a lot of meaning, but it's hard to remember all of it, so that's why we call ourselves SPEER. We are one of 6 regional energy efficiency organizations around the U.S. We're the newest, and you can see that all of the states in the lower 48 are covered by a SPEER except for West Virginia and California. West Virginia has just recently joined SEIA, NEEP, and MEA without any of the others, joined each of them without telling the others they were doing that, so now they belong to 3 RIOs, and that'll get worked out in the end. And California, of course, does their own thing. They set their own standards for energy efficiency. Their energy code is very different. They have their own standards for emissions from vehicles, their own appliance standards. So obviously they're off doing their own thing, and they don't need to be grouped with any other states because what they do is so different from every other state. And they are the real leaders. California and Washington State. Texas plays a big role, though, and I'll get into that. But back to SPEER. We're a member-based 501c3 nonprofit. Our members include Ingersoll Rand through their Train subsidiary, Dow Chemical, just about all of the big manufacturers of building materials, the trade associations like the North American Insulation Manufacturers Association, Air Conditioning Contractors Association. So all of the folks who are involved on a national level in energy efficiency and codes and the type of things that we do are members of our organization. We work in a lot of areas. I spend 90% of my time on codes. We do a lot of other things ranging from building operator certification, so training facility managers so that they know how to operate their buildings the way they're intended to be operated. We have done in the past a lot of work on on-site generation, and so we're pretty wide. We're spread throughout the clean energy, renewable energy industry. One thing that is common through everything we do is that because we're a nonprofit, because we work with so many different groups, we have members that are utilities, CenterPoint Energy, Austin Energy, CPS in San Antonio. We don't implement programs. So we train people, but we don't actually implement programs. So that's pretty much who we are. And what we're going to talk about today is a little bit about the history, how we became a state that has one of the more progressive energy codes in the country, how those codes work in Texas, because it's different than you would imagine. And then we're going to look at that field study, some data, because one of the goals of that field study was to set a baseline or a benchmark for energy efficiency in new construction. So we set out to learn what is actually happening in new single-family construction in Texas, and we have some pretty good information on that. And then we'll look just really briefly at where we're going to go from here. So historically, we have had energy codes in the United States since about 1975. ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, published their first standard 90.1 in 1975, and so that was the very first energy code that we had. It was all about energy intensity. There was very little do this and do it this way. It was about get to this level of energy efficiency without much guidance. And of course, that's where we're heading now again, but we had to take a step back because building officials didn't understand what that meant. Builders didn't understand what that means. So we had to go back from this energy intensity idea to the idea that you have to install insulation, it has to have this much thermal value, and it has to be installed this way. And so that's the way our codes have operated since about 1980 when we made that first change to 90.1. In Texas, believe it or not, Garland did everybody know where Garland is? It's a small suburb of Dallas. Was the first city in Texas to adopt an energy code, and that is because Bahman Yazdani, who is one of the directors of the Energy Systems Lab at Texas A&M, was the city manager or the city administrator then. And he could, so he did, and he felt strongly about it. Austin adopted an energy code in 1985, and it's been kind of hit or miss. You know, all of that time, the big cities, Austin, Dallas, Houston, San Antonio off and on had energy codes, but the rest of the state thought very little about energy codes. Almost nothing. And this is why energy codes are important. So if we look at the progression of energy codes, and I should have my pointer out, but if you look at the dark green line, and using 1975 as your baseline of 100, that dark green line is the commercial energy code, the level of efficiency of the commercial energy code as it's progressed over the last 40 years. And if you look at it as far as the solid line goes, it gets us down to about 48% of that 1975 baseline. So the buildings that are being built today, 2015, 2016, that is the 2015 code that you're looking at there, are about 52% more efficient than a commercial building that was built in 2000. Now, obviously, we've set a goal, Department of Energy, City of Austin, lots of other places, 2030, Architecture 2030 districts, have all set goals for our buildings to be net zero by 2030. And that is that black dotted line that you see going practically straight down. So we've got a lot of work to get to there. It'll be hard to get there. So that's why I say our transition will be, again, away from specific code measures, how do you install that insulation, and going back to how do you get to this level of efficiency. But we're going to talk about that more in the future. But you can see that there are real differences in the level of efficiencies that we've achieved. The red line is heating. We haven't made a lot of progress in heating. And just the technology just hasn't changed that much. But the lighter blue line is cooling. And you can see we've made some pretty significant progress. We've got a long ways to go, but we've made pretty significant progress. But there is a lot of technology out there now, especially on the cooling side, that could drive that line down a lot more quickly if we have the political will to do it. And I think the other stuff up there is interesting, but not anything we have to talk about right now. So I said Texas has had a state energy code since 2001. And so this code establishes what you would expect a state energy code to. It establishes commercial and residential energy standards for new construction, additions, remodels, things like that. We have a separate standard administered by the State Energy Conservation Office for state-owned and higher education buildings. And contrary to what you might think, that's actually a better standard, a little bit higher. And SECO, State Energy Conservation Office, has the authority to adopt new codes. So how did we get here? We went from a couple of cities having energy codes through the 1990s to suddenly in 2001, Texas was not a liberal state in 2001, 2001 becoming a state that had a statewide energy code. Well, what was happening in 2001? So two things really important were happening. One was that for decades, Los Angeles had had the worst air quality in the country. Houston was second, sometimes third, sometimes fourth, but mostly around second. But then in the 1980s, Los Angeles, California, started getting serious. Los Angeles and the state of California started getting serious about efficiency and air quality. And they started driving their air quality curve way down. And in 2000, those lines crossed. And Houston became the most polluted city in the country. We were having an election in 2000, presidential election. Does anybody remember who was running? It was George Bush and this guy Gore, and what was his big stick? It was energy efficiency, wasn't it? Houston was an embarrassment. Another thing that was going on was that, pardon me just a second. Now I've got a stick to wave around, I can talk. So the other thing that was going on was that these areas over here around Dallas, this group of counties in East Texas where we have a lot of coal-fired power plants. Houston, where we have a lot of manufacturing, a lot of energy industry. The Austin-San Antonio corridor, which has a lot of transportation, has always been right on the verge of air quality attainment or non-attainment. And Corpus Christi, where they have a lot of refineries and a big naval base, a couple of counties around there. All of these counties, and Victoria County, we're going to forget El Paso County now, for now, because they weren't part of this. All of these counties were trying to write their parts of state implementation plans to get themselves into or stay in compliance with EPA air quality standards. And as they were writing these plans, of course, the big thing they were looking at was nitrous oxides. And as they were writing these plans, they were coming up with all kinds of wonderful ideas of how they could reduce their NOx emissions. And, you know, most of them had something to do with putting a scrubber on a smokestack, either on power plants or on the chemical plants around here. And of course, this was real popular with industry. You know what the most important lobbying group in the state of Texas is? The American Chemical Council. They represent all of these people owning these chemical plants and refineries down here. Transportation has a lot of power up here. So all of these ideas that were coming up were not very good. Another great idea that was being tossed around was, you know, we're looking at diesel. Primarily, you know, diesel transportation fumes are a big part of NOx. So we were looking at that and thinking, you know, if we could get diesel construction equipment or even diesel trucks off the road from 7 in the morning to 11 in the morning That would be a great idea. That, of course, was also very popular. And then some brilliant person, and actually I think I know who this is, but I'm not sure. I think it was Tom Smith. Smitty went to the legislature and started talking to a few people and said, you know, building energy codes would reduce emissions or at least maintain the level of emissions from power plants. And the legislators started thinking about that, and they said, a lot better than getting diesel trucks off the road, a lot better than beating up on the people who give me checks from the American Chemical Council every year, so maybe we can do this. And suddenly in 2001, we had a state energy code. Of course, legislature didn't like the idea of calling it a code, so they called it the Building Energy Performance Standards, but it's a code. So that's how we got to a code, and it was about air quality. Remember this map, we'll come back to it. So part of that legislation gave, established a process where we could adopt new codes and gave the State Energy Conservation Office the authority to do that. And so we had set the stage where we had an energy code that was in effect across the entire state of Texas. And what did that really mean for the average builder building your house, your mother's house, your uncle's house? What did that mean? Didn't mean much of anything, except the builders had a liability. But Texas is what we call a home rule state. The legislature likes to adopt laws, but the legislature doesn't like to enforce laws. So they said, local jurisdictions, municipalities, cities, towns, villages, you're responsible for enforcing this code. And of course, codes are meant to be amended, but since we're focusing on air quality, we're going to set up two standards here. How many counties does Texas have? Jackpot. There you go. So we've got 254 counties, and in 212 of those counties, 212, yes, you can amend the code any way you want to. You can take everything out of it. As long as it's still got the label, we're okay with that. But in 42 counties that are near non-attainment, near non-attainment or non-attainment, if you want to amend that code, you have to write a request to the Texas A&M, the Energy Systems Lab, and get them to tell us, State Energy Office, that that amendment doesn't weaken the code. Fortunately, about 80% of the construction in the state is in those 42 counties. So we do have a pretty good code. And the truth is, there are a couple of cities. Anybody here from Amarillo? Okay, Amarillo is famous for adopting a new code and then amending it back to the 2006 IECC. So they've got the 2015, but they've amended it back as far as they could. A couple of others like that. So we've got a state energy code. It actually applies to about 80% of the buildings. It actually applies to 100% of the buildings, but it's being enforced pretty good in areas where about 80% of the construction was done. And local jurisdictions have some requirements under the law. This is State Health and Safety Code. They have to establish procedures for the administration and enforcement of the code. That basically means they have to adopt the code and put a process in place where they're going to issue permits and do inspections and issue certificates of occupancy. They have to make sure the people who are enforcing the code are certified by the International Code Council and so know something about the code. And then they have to track and report the implementation of their codes to SECO. Nobody does that last one, but the first two actually happen. So, code adoption is the responsibility of the cities. So, why do we have people like me who go out and work with cities every day to try to help them adopt the right code and make sure they can enforce it? Well, I have come to the conclusion that 90% of the mayors in the state of Texas have a brother-in-law or a sister or an uncle or a father who are builders. And they're being lobbied every day not to adopt new energy codes. And so I show up in this building official's office. So I show up in Orange, Texas. And I walk into or I've made an appointment, I walk into the office and I say, I know this guy, he's a pretty good friend of mine actually. And I say, you know, we've got a new state energy code, the 2015 IECC. And you guys are still operating on the 2003. That was 3 code cycles ago. When are you going to change? And my unnamed friend looks at me and says, if I don't do this, what's going to happen? Somebody from the state going to come down here and put me in jail? I said, no. My boss going to get a letter from the state saying I should be fired? No. I said, well, what's going to happen? Nothing. Because the state's not going to enforce it. So, and, you know, looking at it from his perspective, this is a hard job. He's already got a full-time job, and we're expecting him every 3 or 6 years to sit down and write an ordinance that will adopt this code, that will make the local amendments. So my buddy in Orange is in a windstorm zone. So he has to rewrite the whole windstorm section every time he adopts a new code and get all those amendments together. And then he has to take it to the mayor and the city council. And you know what they think about code adoption. And they're not for it. And so, you know, why is this guy going to do this? And so it comes down to education. We have a couple of tools. There's a thing called the Insurance Services Office that rates the bond ratings for cities. And very few people know about this until they get an audit by them. Very few cities know about this until they get an audit by them. And so we go down and we do the education, we do the outreach. And that comes to the most important thing that we do. So get past that one. We put together collaborations of folks to go out and do the training and to educate these folks about what's going to happen, why they have to adopt the code, So another secret of this industry is that every code change costs $30,000. If you raise the wall insulation level from R13 to R15, it costs $30,000. If you raise the HVAC, the air conditioner efficiency requirement from 13 SEER to 14 SEER, it costs $30,000. At least that's what the lobbyists tell everybody. The number is $30,000. Doesn't matter what you're doing. I've been in 100 hearings. It's always $30,000. This is going to cost $30,000, and it's going to price everybody in the state out of a home. So we have to give them those real numbers. It's important. And we have partners. You know, SECO hires contractors every time there's a code change. We do a lot of training. There we go. I'm talking about A&M again. ESL does some training. ICC, the International Codes Council, does some training. And we all get out there together, and we try to touch people. Code officials, builders, contractors, make sure that they understand what the code actually says, what the real cost of those code amendments is, other than $30,000. And so this is the number of people that we've touched in the last 2 years. About 6,000 people, 6,600. SPEER is responsible for about 4,000 of those. And there are more, but those are the numbers that we have that are good. And the reason we have to do that is this. In 2012, the State Energy Code became the 2009 IECC was adopted as the State Energy Code. And you can see that 3 years later, 41 cities out of the top 210 were still on a code earlier than in 2009. This is 3 years after code adoption. And that's because of all the things in that conversation I had with my buddy in Orange, Texas. We had people who had moved to the 2012. We had a couple that had even moved to the 2006. And then on September 1 of 2016, the 2015 became the code. And so there we are a year and a half later, and we're already beyond that level that we were 3 years into the code cycle with 2009. And like I said, well, I didn't say this. These cities, 101 of the 200, there are about 220,000, about 220 cities in Texas that have a population of 10,000 or more. And those are the ones we track most closely. There are another 100, there are 1,200 cities, towns, and villages in Texas that have the authority to adopt a code. 600 of them don't do anything. Another 100, they have one person who's responsible for everything, so we don't focus too much on them. It's the large cities that matter, and if we count these two codes together, they have about the same level of energy efficiency. There's 1% difference between these two. About 90% of the permits being issued in Texas are issued under one of these two codes. That's how much impact these cities have. So how many permits is that? Why is this important? Anybody have any idea how many single-family permits are issued in Texas? Let's say in 2016, since that's the last year I have a number for. Guess? 40,000? That's ballpark of the guesses I get. It's 108,000. Those are the ones that are permitted in 1 year, and that's 15% of all the new construction in the United States, new single-family construction. On the commercial side, we're at about the same place. By dollar value, Texas accounts for about 15% of all new construction in the United States. So what we do here is important, and the fact that we're one of only 12 states in the U.S., last I looked, we're only one of 12 states in the U.S. that have adopted the 2015. So because of the volume of the construction that we do, and the fact that we're leading, this is where we really are leading, because of the fact that we were one of the first states to adopt this code, and we're getting compliance and enforcement from a lot of people, what we do here is really being watched all across the country. But what does adoption really mean? Does adoption equal compliance? Some people think so. And we had this discussion we had this discussion ongoing for a number of years. And a lot of people say it's adopted, the builder has the responsibility, has a legal liability to do this, so adoption should equal compliance. I don't buy that, and I've seen studies over the last 10 years that will put compliance at 40% or 90% or some number in between. The problem is none of those studies has the same definition of what compliance is. Some will say adoption, some will say the number of measures properly installed, some will say the number of hours building inspectors spent enforcing this code, some will say it is the energy use per square foot of a building compared to a benchmark. If buildings are achieving this level of energy efficiency or energy use per square foot more accurately, and this is the benchmark, then they're in compliance. Well, that's a pretty good way to look at it, if you figure out what the baseline is. So that brings us to the DOE Residential Energy Code Field Study. And the goal of this field study was actually to determine one of the goals was to determine what is the benchmark. What is the level of energy efficiency in new homes being built in 8 states across the United States? Had some other goals. We wanted to quantify the impact of an intensive outreach and education program. You would naturally say, yeah, it's going to have an impact, but nobody's ever tried to quantify it before. And then in DOE speak, we wanted to provide the business case for private sector investment in energy efficiency. In real world language, that is give the utilities, the investor-owned utilities around the country, the information they need to set up effective energy efficiency incentive programs. So those are the goals of this field study, and that's where we're going to shift and start talking about that field study now. And the field study was conducted, like I said, in 8 states, the residential field study. Pennsylvania, Maryland, Kentucky, North Carolina, we're trying to call that Virginia, Georgia, Alabama, Arkansas, and Texas. There were a couple of states, Missouri, Michigan, West Virginia, that collected data, didn't do the whole field study. And then there are also some other DOE-sponsored field studies. There's a commercial field study and a multifamily field study. Those 2 studies are really about trying to figure out how to establish a methodology to do what we did in residential, because those two sectors of the industry are much more difficult to quantify. That was our team, National Association of State Energy Officials, the State Energy Conservation Office, and because we're targeting utilities to get them to improve their efficiency programs, the Electric Utility Marketing Managers of Texas. This is the industry group that actually sets and oversees the efficiency programs of the investor-owned utilities in Texas. So Texas is a big state. All the other 7 states did their study across the entire state. But we only looked at 30 counties down here in southeast Houston, from Matagorda Bay to Louisiana, and from the Gulf Coast up to Waller County. But, you know, these 30 counties represent about 25% of the state population and about 30% of the permits. So working with Pacific Northwest National Laboratory, we determined that we could do the study here, and we could extrapolate it to be representative of the entire state. And people always ask me why we didn't do the entire state, and that's why. This is the first mile sign you see when you cross into Texas on I-10 from Louisiana, just outside of Orange, where my buddy lives. It's about 853 miles from Brownsville, at the farthest southern point of the state, to Dalhart up in the Panhandle, right up on the Oklahoma border. So if we had done the entire state, we'd have spent all our money on gas, driving around. Here's the timeline. I think the important thing is that we're wrapping up our education and outreach. Well, so the data from the study that I'm going to show you here was collected from October of 2014 to October of 2015. That was the data collection phase. A lot of that time was spent in preparing for it. Actual data was collected from March to October. For 2.5 years, we've been out doing intensive outreach and education, and in April, we're going back out into the field to repeat the study that I'm going to talk to you about here. We only looked at new single-family homes under construction, no occupied homes. We only visited each home once. So, and we had 2 types of visits, either at what we call the rough mechanical stage, which means the insulation and the equipment are all in, but the drywall is not up, or at final, and final is what you would expect final to be. We were looking at individual code measures, so the window efficiency, the HVAC efficiency. We weren't looking at whether the house complied with code, the entire house complied with code. Since we only visited each house once, we couldn't. And that was a big selling point of the study, because so that we could tell builders and jurisdictions that we were not playing gotcha. We weren't there to see if any house complied with the code, any jurisdiction was enforcing the code right, any builder was building to code. That was not important. We were taking a snapshot. We had to have a minimum of 63 observations. And I'll talk about, so an observation is not a visit to one house. An observation is collecting one sample of each of these critical measures. So that can't be done on one house, because you can't look at the lighting when you're looking at wall insulation, because the walls are going to be covered up. And the lighting won't be put in until the walls are covered up. So that's an example. So it takes at least 2 houses to give you a full observation. This is kind of the general makeup of the form. Had about 150 questions on it. These are the measures that anybody would expect. Envelope leakage, duct leakage, insulation, window efficiency, and lighting. Those are the big ones. But like I said, okay, I'm lost. Okay, let's skip that. So like I said before, here we go. So there were about 150 questions, and as long as we were collecting information here, we collected all of this information. But this is all, we were able to analyze this information. This is the information that's used in the modeling, but this information we were able to develop some really interesting stuff out of, even though it's considered peripheral to the modeling. So can we just go out and look at 130 houses somewhere, 140 houses? No, we had to. So we've got our requirement that we have to have 63 sets of observations. We know what an observation is, and so then we have to determine where we're going to do our samples. So we looked at the cities, permit history. Well, first we looked at incorporated areas, cities, and unincorporated areas of counties. And we know that statewide, about 2/3 of the houses are built in cities, and 1/3 are built out in the unincorporated areas. And so that's how we divided our 63 observations. 2/3, 1/3. Then we looked at all the cities. This is certainly not all the cities in that 30-county area, but we looked at them and created a sample plan. Houston obviously has the most construction, so we collected 17 samples there. Lumberton doesn't have much. We collected 1 there. But based on historic permits, population, demographics. Same thing down here. Harris County has most of the construction, so that's where we collected most of the samples. What did the houses look like? 2,700 square feet, a little bit bigger than the national average. 2 floors, 1.8 floors, 2 floors. Most of them were permitted under the 2009 code, a few under the 2012. 26% of these houses participated in a utility program. We tried to avoid above code program houses, but we wound up with some anyway. All of them were slab on grade. There were no pier and beams, no elevated houses for, windstorm or anything like that. Most of them had gas furnaces. Most of them had gas water heaters. Ventilation, you probably don't care about. There's a requirement in the ventilation code for ventilation. Nobody does it right. The requirement is not very strenuous, and nobody even does that right. So let's go on. So what do we find? As we go through these slides, the green line will always be the 2009 code. The red line will be the 2015 code. Now sometimes we'll have other lines because the code will say you have to do this in climate zone 2 and this in climate zone 3. So climate zone 2 is basically the southern 2/3 of Texas. And climate zone 3 is the northern third minus the panhandle. Panhandle's in climate zone 4. So there's a requirement in the code for high efficacy lighting. And this is basically the equivalent of CFLs or LEDs. Code requirement was that 50% of the permanent fixtures in the house had to have high efficacy lighting. That changes under the 2016 code to 75%. And we have a curious observation here. We have about the same number of houses. We had 66 total observations. We have about the same number of houses that either did 10% or 0 as did 90% or 100. And not a whole lot in between. When we looked into this, it was basically, these folks didn't have a clue. They didn't know that you couldn't put LEDs on an incandescent dimmer, and so they had done that, and the dimmer hadn't worked, and they said, these LEDs are no good. These guys knew what they were doing. Education. Envelope leakage. So ACH 50 is air changes per hour at 50 pascals. That's just a pressure. And air change per hour is exactly what it sounds like. All of the equivalent of all of the air in a house, the volume of the house, under this level of pressurization would be evacuated or drawn into the house depending on whether it's pressurized or depressurized, just through the leaks in the walls, and that's what we're testing, for the leaks in the walls, the ceiling, the foundation. Under the 2009 code, the requirement was 7 air changes per hour, and all but 2 houses. We had 64 observations. All but 2 houses passed this. If you had told me before the study started that all but 2 houses were going to pass this, I'd have said, you're crazy. It's not going to happen. And we tested all of the houses ourselves, so we didn't rely on any previous testing. We did our own tests. And then the 2009 for climate zone 2 goes down to 5 air changes, and in climate zones 3 and 4 it goes down to 3. And you can see we're in pretty good shape in climate zone 2. These guys can be brought down without much problem. Getting these guys down here is going to be a lift. But we're not in bad shape. This is actually pretty good. And we can look at the other states and see where they were. So here we are at Texas, 4.69. Basic requirement was 7. Maryland had a higher requirement. Their requirement is 3, and that was because they had just adopted a new code. They were getting close to it. Kentucky showed us something we always thought. For whatever reason, there's a provision in the code that says that you have to test the ducts or the envelope, and it has to meet those levels that I told you about. But if all of your ducts are in the conditioned spaces within the thermal envelope, you don't have to test them. And so for whatever reason, in Kentucky, they've developed a construction culture where about half the houses are built with the ducts in the conditioned spaces. And so they didn't have to be tested. But we tested them. Or the team working in Kentucky tested them. I wasn't there. And what they found was that the ducts that had to be tested all met the code. And the ducts that didn't have to be tested, they had some that were up 16, 17, 18, 20 ACH. And that's been the assumption that we've all had for a long time, is that the biggest predicator of envelope leakage and duct leakage is knowing that your house is going to be tested. They just proved it for us. Window efficiency. So there we are on 2000. Well, that's okay. So there's 2009. Here's 2015. We got it. Almost everybody is already building the 2015. The window manufacturers got out ahead of everything here. You can't buy windows that don't meet the new code. It's a good thing. Window insulation value, same thing. Here's climate zone 2, here's climate zone 3, and we've got these 4 outliers up here. Probably all from the same builder. But interesting. So windows are a real positive story. Ceiling R value. So ceiling, you've got a requirement for R30 or R38. In this case, it was R30. And you take a machine up there and you blow insulation around until it gets to a certain depth, and you're in good shape, right? Should be pretty easy to do. These 2 guys are not really outliers. It's a different compliance path that allows you to use a less amount of insulation in some places and make up for the energy efficiency in a different place. So ceiling insulation is pretty easy to do, right? I told you just blow cellulose or you blow fiberglass, and all you have to do is make sure it's that thick and it's consistent. Well, that's what installation grade is. And out of 49 observations, 36 of them were at grade 1, which is good. But 13 of them weren't. I mean, this is as simple as you can get. You're just blowing stuff on the floor. But they didn't get it right. And I think this number is probably exaggerated, but that's beside the point. Same thing here. Wall insulation is a little bit more difficult. But out of 62 observations, we had 38 that did a good job, and we had 24 that did a questionable job. So this is a big deal. how can your HVAC system work if you don't know what level of insulation you have? If you got big gaps in your insulation, it doesn't work. So that's a big deal. So by state, you can see that Texas, on the insulation grading, the quality of the installation of the insulation, Texas did a pretty good job, Maryland did a good job. Arkansas is probably okay, though they didn't have a lot of observations there, and everybody else was worse. Again, you know, we might be exaggerated there, but you can see there's still a lot of room for improvement. So duct leakage. So we spend 40%, really, we spend 40% of the money that we spend to run a house on heating and cooling. And all of that 40% worth of heated or cooled air, 40% worth of our dollars worth of heated and cooled air has to flow through the ducts. And in 2009, we allowed 12 CFM leakage per 100 square feet of conditioned space. Under the 2015, we go down to 4. Now, if we had done this, we did this 20 years ago in Austin, and the numbers were up here. And so, you know, we got a few bad ones here, but truth is we're doing pretty good. By state, I don't know what happened in Pennsylvania. Something wrong there. But, you know, again, we're doing pretty darn good. This surprised everybody. So you have your SPEER rating is a seasonal energy efficiency rating of your cooling system. And by proxy, it's the efficiency of your heating system as well. Oh, that's duct leakage by state. Sorry, I went the wrong direction. Okay. Where's my SPEER rating? I got the old graph. You're right. Okay, so I copied the wrong table. Texas. Wow, this is bad. So Texas is really good. We're at 15.1. You just can't see it there. The code requirement when these houses were built was 13. So we're actually building really efficient homes. We're installing really efficient equipment in our homes. All of the rest of these were at around 13 or slightly above. Texas should be up here at 15.1. Sorry about that. I wonder how many times I've done that. The thing that we're missing on is sizing of our system. We've got about 600 square feet per each ton of air conditioning installed. Ton is 12,000 BTUs of energy. And this should be up here. So we're installing really tight systems with really efficient equipment, and we're oversizing it. And that's really a bad deal because that creates more humidity, allows more humidity together, but that's one of the things we're working on. So what was the final result we're looking at? This is a hard table to look at, but this black line is the energy use intensity in BTUs and of the 2009 code, and that would be 25.94 annual BTUs per square foot of conditioned space. The average home we looked at, the typical home we looked at, and all of these lines represent about 1,500 different iterations of our model, was 21.08. So we're actually building Texas builders are actually building more efficient, when this was done, than the 2009. That doesn't mean there weren't savings. Remember we talked about lighting. Envelope leakage, there were a few that were off, but look, this is 2014 number. It's 108,000 last year, and probably more than that this year. So the number of houses is big. This is the actual savings that is still on the board, despite the fact that we're building pretty good houses. This is 16.5 million total here. Cumulatively, over 30 years, that's 3.1 billion, without any growth in the number of houses. So that's an incredibly large number. We made this change. If we brought all of these measures up to 100% compliance, kept them there for the next 30 years for every house built, then it would be $3.1 billion. So Texas builders are doing a good job. Some of the things that we're looking at going forward is using utility building data to evaluate efficiency, so we don't have to spend $1.5 million to go out in the field and measure energy efficiency twice in 8 states. One of the big conundrums right now is how do we incorporate on-site renewables into building codes without reducing the efficiency of the envelope? It's hard. It really is hard because builders want to balance their costs, and PV costs more. But efficiency advocates don't want to lose any insulation value, or they don't want to lose the tightness of the envelope. So that's a big issue that we're working on. In Texas, we're looking at code compliance in unincorporated areas, and you know that's a talk in itself. And then, of course, we're looking at beneficial electrification. Those of you who know what that is it's shifting the loads that we have, the fossil fuel loads that we currently have in buildings, so the heating, the water heating, shifting those from natural gas to electricity to smooth the way for a renewable grid. The timing on that has to be done properly. And we're talking about, if 45% of our electricity is still coming from coal, is it time to start that transition yet, or are we still too early for it? I'm not going to weigh in on that right now, but that's the question that everybody's looking at. So that's kind of the state of building codes in Texas right now. Thank you.
Questions for Richard?
Is there good data comparing multifamily building energy use with single family?
No.
Okay.
We're working on it. There's the multifamily study that's going on right now, and one of the things that really what they're working on is the methodology. So what is the information we have to collect? How can we collect it and have that information, that data set, large enough to really be meaningful without breaking the bank? Because it's hard. Smart Meter Texas is one option there. That's this incredible set of data that is every utility bill in the state of Texas for the last 6-7 years. It's real hard to access now. And we're working on getting easier access to that for researchers, program implementers, folks like that. But right now, the answer has to be no.
Let me ask you to follow. Let me ask a follow-up. When you say hard to get, you mean it's difficult because the data are not organized well, or it's hard because people make it hard for you to actually access it?
The data is really good, and it's organized well, and the Public Utility Commission is real concerned about privacy issues for the customers. So the only way for, say you're an aggregator, you're a program implementer or an aggregator or somebody, the only way for you to get access to her, that billing information, is for her to go online, set up an account, go through a pretty elaborate process to give you permission to do that. And of course, you don't want just hers, you want 100,000. And that's real hard to do. The step that we think is going to happen within the next 6 months is that you, under the auspices of the PUC, would be able to set up a website where account owners could log in just using their account number and give you permission to access that site. And that would be the difference between night and day.
Hello, thank you. First of all, really great presentation. So I have a question regarding the next step of
Yep.
the slide. So you mentioned billing data. So could
Yeah,
you please?
that's what we were just talking about.
Yeah. So
Mm-hmm.
I mean, I'm talking about some other aspects. So
Mm-hmm.
so those billing data are the whole house consumption level, right?
Utility billing data is typically whole
Yeah.
house consumption
Yeah.
levels.
So how do you separate, like, which measure can you? I don't know.
So the first level in determining where you are is figure out what the universe of available data is. And then having the billing data would allow you to create a study where instead of having to look at 100,000 sets of data, you could say, okay, I want this band of 10,000 because they're really efficient. And then you could set up a study where you could set up a simple data logger where you got nothing but energy and time. And based on the energy and time, you could disaggregate, and you could come up with some pretty good data about how much energy your air conditioner is using because of the shape of the load that air conditioner draws. We know that. Or you could set up multiple data loggers or some other type of system where you could monitor different circuits. So you could monitor the air conditioning circuit. You could monitor all the lighting circuits. You could monitor the water heatings. Well, water heating was done electrically.
Oh,
So there are a lot of different ways to do it.
okay. So the billing data was sort of serve as an initial filter to find out
Right.
which. Okay. Okay, that makes sense. So
It goes much further than that, though, because we really don't know. You can look at just knowing the efficiency of houses by age cohort is really important because we know what went into houses at different times. So there's a lot that we could do with that.
okay. So I have another question regarding the sampling. So in the sampling, you said, for example, in East Texas, you collected 42 samples, about 40-something samples. Combining all those counties together, I remember Houston has 17. That's the most. So how do you come up with 42? Did you balance the statistical calculation? There's a formula to calculate what the effective sample size is, and is it a balance between those statistical calculation and the actual money, the actual cost? How is this 42 come up? Is it statistically valid
Okay,
to come up with a
so the
number?
42 comes from the fact that we determined that we needed 63 full sets of observations to have a statistically valid study. The Pacific Northwest National Lab figured that out and said ran whatever calculations they did and said this will be a valid study if we collect 63 sets of observations. We know that in the state of Texas that about 42%, that about two-thirds, about 66% of the homes are built in cities where jurisdictions, so incorporated cities, and about one-third are built in the unincorporated areas of counties. So the 42 represents two-thirds of the 63 samples that we had to collect, and they all came from the cities. The other 21 came from the unincorporated areas of counties. And so it was replicating the balance of what's actually built to get to our 63 observations.
Okay, thank you.
Thank you. How is related this data that you have for your study with other data from other programs such as Energy Star, the Energy Star program from the U.S. government?
That's kind of next steps. And Energy Star, we believe that there are a number of different ways to do what we did here by going out into the field. But this does give us a set of data, and we're going to get another one. We're going back out into the field to collect a second set of data. So by having that information, getting historic information, not necessarily from Energy Star, because Energy Star is a smaller sample and it's intended to be high efficiency. There's probably something we could do with that. But we believe that using DOE's code compliance tool, ResCheck, we know we can get the data from that, similar to that data to what we've got here. We know that we can get the HERS energy, the home energy rating systems data for Texas for 3 years. So by having all of that data and then having this data as a baseline to look from, we believe we can develop a methodology where we can use Smart Meter Texas, where we can use ResCheck, where we can use RimRate, ResNet data, and recreate this study without having to actually spend as much money and go to as many houses. There probably still need to be some on-site data collection, but I think we could streamline the process a lot.
I think that's a good question. I was going to kind of ask, what's in your time and energy efficiency of buildings, what's changed or what's been the biggest change? Has it been, well, if you have smart meters, how much information can you know from smart meter data that you just couldn't know before? And yeah, does it make it, how much more easier does it make it to assess what the building efficiency actually is out there? Because I have a friend who got a house in West Texas, and he can get more information than we get in Austin just due to the meter he put on, or the controller, like his thermostat, and he can get it, gets a breakdown by air conditioner, heater, dishwasher, et cetera. Right. And so he doesn't know anything about his home efficiency, but he knows that. So, but you know about home efficiency. So given those data, you're probably pretty dangerous. Or you're safe in that you help us understand.
So meter data, having access, having AMR meters, smart meters, on basically every home in Texas. There are a few that have opted out. They've had to pay a fee to opt out. Every building in Texas has incredible potential. We barely started tapping that potential yet. 2 years ago, nobody thought we could disaggregate meter data, just time and energy, taking that. But the same people who were saying 2 years ago you can't do that are now saying we can identify just about every load in your house just by looking at the shape of that load. What is happening over what period of time? And you don't have to monitor every circuit. So most of the time I spent at Austin Energy, we had a whole team of engineers running models on the little bit of data that we could collect and trying to tell us what our program should be, or how we could improve our programs, or how we could build our programs. But when we can get to that level that I was just talking about, of specificity about what's happening in a cohort of houses, you can't do it on any individual house, because it's just not valid. But if you do it on a cohort of houses, existing homes, 10 to 15 years old, 2,500 square feet. Believe it or not, you can find a valid sample of those homes. You can look at those homes and you can target programs. And, I work mostly in new homes because that's where most people do work, because it's easier. But existing homes is where the value is. That's where the real improvement will be made. And so having access to that kind of data, and over the next 5-10 years, developing the programs that will allow us to do that kind of analysis and pinpoint programs, efficiency programs, incentives, whatever, at individual cohorts of homes is an incredible improvement, something we wouldn't have imagined 15 years ago. Thank you. Thank you, Kerry.
Yeah, thank you. I want to ask on the record, ask another question.